Hess law, that is the indirect measurement of enthalpy. So Hess law of constant heat summation, its example and its explanation, and first law of thermodynamics, that is a special case of Hess law. These two topics are discussed in part 1 of the video, and there are some numerical problems regarding Hess law. It will be discussed in the part 2 of the lecture. Calculate the heat of formation of an aqueous solution of ammonium chloride from the following data. Ammonia gas, when it is treated with water or aqueous medium, it will produce ammonia aqueous, and the amount of heat release is minus 35.16 kilojoule per mole. HCl, hydrochloric acid, in gaseous form, when it is dissolved in water, it will produce hydrochloric acid in aqueous form, and the amount of heat release is minus 72.41 kilojoule per mole. Also, there is third reaction given, ammonia in aqueous form, it is combined with HCl in aqueous form, and it will produce ammonium chloride in aqueous form. So here in question it is given aqueous solution of ammonium chloride. So first we will form the ammonium chloride and then we will treat it with aqueous solution. So we will solve it. Adding reaction 1, 2 and 3, these three reactions. To obtain the reaction ammonia in gaseous form, it will combine with HCl, hydrochloric acid, in gaseous form, and it will produce ammonium chloride, which means that ammonia in gaseous form, hydrochloric acid in gaseous form, and it will be combined with aqueous, it will produce ammonium chloride. So the reactions are given: ammonia in gaseous in aqueous form, HCl gas in aqueous form, and aqueous ammonia combined with aqueous hydrochloric acid, it will produce ammonium chloride. If we look at this reaction, there are some common terms that are present towards the reactant product side and also towards the reactant side. So these same term will be cancelled out. Ammonia aqueous, that is toward the product side, and it will cancel out ammonia aqueous, that is towards the reactant side. HCl, hydrochloric acid, will cancel out hydrochloric acid. So we will get ammonia in gaseous form, it will combine with hydrochloric acid in gaseous form, and also it will combine with water, that is AQ, it will produce ammonium chloride. Now coming towards the enthalpy change or heat content, we will sum up these three values: delta H1 plus delta H2 plus delta H3. Delta H1 is minus 35.16 plus, delta H2 is minus 72.14 plus, and delta H3 is minus 51.48. So minus plus will produce minus, here the minus plus will produce minus, so we will get all these value with minus sign, and we will sum up these value that will produce minus 159.05. So 159.05, it is the heat or enthalpy change when aqueous ammonium chloride is formed. Apply Hess law to calculate delta H naught for the sublimation of 1 mole of iodine from the following equation. Sublimation is the conversion of substance that is in solid form directly to gaseous form. So two reactions are given in which the H2 hydrogen gaseous form, it will combine with iodine in solid form, and it will produce 2 moles of hydrogen iodide. The heat content or the heat energy release gain is equal to 51.8 kilojoule per mole. Second reaction, hydrogen gas, it will combine with iodine gas, it will produce 2 mole of hydrogen iodide gas, and the heat release will be minus 10.5 kilojoule per mole. So we will solve it. Sublimation is the conversion of solid to gaseous form, directly to gaseous form. So our desired reaction will be iodine solid that is converted to iodine gaseous form. So here if we look at this reaction 2, the iodine gas is present to the reactant side, and we want it to product side. So we will invert this reaction, which means that 2 mole of hydrogen iodide, it will move towards the reactant side, and hydrogen plus iodine gas both will move towards the product side. Now by inverting this, we will invert the sign, that is minus 10.5, it will be converted to plus 1.5. So here it is given, hydrogen gas, it will combine with solid iodine, it will produce 2 mole of hydrogen gas, and hydrogen iodide, we have inverted the reaction 2. Hydrogen iodide, it is converted to hydrogen gas and iodine gas. By inverting this equation, the sign of enthalpy will also invert. So here it is minus and we will convert it to positive. Now there are some same term, that is hydrogen iodide, it will cancel out with hydrogen iodide in reaction 2. Hydrogen in reaction 2, it will cancel out with hydrogen in reaction 1. So we will get iodine, that is in solid form, it is converted to iodine in gaseous form. That is the sublimation, in which the solid is directly converted to gaseous form. Enthalpy change, that is equal to delta H1 plus delta H2, 51.8, that is the delta H1, plus 10.5, that is delta H2. So we will get 62.3. 62.3, that is the heat of sublimation of iodine. Determine delta H for the following reaction with the help of given data. 2 moles of carbon, it will combine with 2 moles of hydrogen and it will produce ethene molecule. We will find the enthalpy change for this reaction. 3 further reactions are given, in which the carbon dioxide is produced, water is produced, and third is the combustion of ethene. So we will solve it, multiplying equation reaction 1 and 2 with 2 in order to get 2 carbon and 2 hydrogen, and inverting equation 3. If we look at the desired reaction, in which 2 carbon and 2 hydrogen are combining, so we will convert these two reactions, that is carbon solid combined with oxygen and hydrogen gas combined with half mole of oxygen. This will be converted to 2, because in desired reaction here 2 moles are given. So we will multiply reaction 1 and reaction 2, including the enthalpy change, with 2, and inverting equation 3. If we look at the desired reaction, in which the ethene molecule is at the product side, and in this reaction ethene molecule is at reactant side, so we will invert its position. Ethene plus oxygen will shift it towards the product side, and carbon dioxide and water will be shifted towards the reactant side. By doing this, we will change this sign from negative to positive side. Now adding these 3 equations, so first we will multiply the reaction 1 with 2, also the enthalpy change is multiplied with 2, reaction 2 with 2, so 2 mole of hydrogen and half is also given, already given, so we will multiply it with 2, 2 and 2 will cancel out, and we are left with 1 mole of oxygen. Also the enthalpy change is multiplied with 2, so minus 285.7, it is multiplied with 2, we will get minus 571.4. Inverting reaction 3, so carbon dioxide and water will be shifted towards the reactant side, and ethene and oxygen will be shifted towards the product side. By doing this, we will invert, or we will reverse the sign from negative towards the positive side. Now we will cancel the same term and sum up the enthalpy for finding the change enthalpy. So here we will look at the reaction. 2 moles of carbon dioxide, it will cancel with 2 moles of carbon dioxide. 2 moles of water will be cancelled out with 2 moles of water, and 3 moles of oxygen, it will cancel out with 3 moles of oxygen. In reaction 1 there are 2 moles, and reaction 2 there is 1 mole. So all these will combine 3 moles. So here the 3 moles will cancel out with 3 moles. We will get a reaction. 2 moles of carbon solid, it will combine with 2 moles of hydrogen and it will produce ethene molecule. Now coming towards the enthalpy change. According to the Hess law, we will sum up all these reactions, these enthalpy. So we will get 72.1 kilojoule per mole. 72.1 kilojoule per mole is the change in enthalpy that is used for the formation of ethene molecule. Liquid ethanol when burned in oxygen at 25 degrees C liberates heat delta H is equal to 1402.14 kilojoule per mole. The heat of formation of carbon dioxide and water are minus 393.5 kilojoule per mole and minus 285.7 kilojoule per mole respectively. Calculate the heat of formation of ethanol. Here three reactions are given, in which in first reaction the carbon dioxide is produced, that is releasing the heat minus 393.5 kilojoule per mole. In second reaction, liquid water is produced, that is releasing the heat minus 285.7 kilojoule per mole. In third reaction, ethanol is combusted in oxygen, burned in oxygen, and it is producing carbon dioxide and water. Multiplying reaction 1 with 2 and reaction 2 with 3 in order to get 2 mole of carbon dioxide and 3 mole of water. If we look at the third reaction, here are 2 moles of carbon dioxide and 3 moles of water. So we will convert this H2O, water and carbon dioxide, into these values. So we will multiply the reaction 1 with 2 whole term including the enthalpy, and we will multiply reaction 2 with 3 whole including the enthalpy, and we will invert the reaction 3. Carbon dioxide and water will be shifted towards the reactant side, and ethanol and oxygen will be shifted towards the product side, and also we will reverse the sign of enthalpy to plus sign. So here the 2 moles of carbon, it will combine with 2 mole of oxygen and it will produce 2 mole of carbon dioxide. This term will also be multiplied with 2. We will get minus 787 kilojoule per mole. Reaction 2 is multiplied with 3 and including the enthalpy change. So we will get 3 mole of hydrogen. It will here half mole of oxygen is given, it is multiplied with 3, so we will get 3 by 2 oxygen, and it will produce 3 moles of water. 3 by 2, it is also written as 1 and 1 by 2, so it is replaced with 1 and 1 by 2 mole of oxygen. Inverting the reaction 3, so here the 2 moles of carbon dioxide, it will combine with 3 moles of water and it will produce ethanol and water. Also reversing the sign of enthalpy, here it is minus given and we will convert it to positive sign. Now sum of these equations. 2 mole of carbon dioxide will cancel out 2 mole of carbon dioxide, 3 moles of water will be cancelled out with 3 moles of water, and 3 moles of oxygen, it will cancel out. Here it is given as 2 moles and 1 from the second equation. So 2 and 1 will be cancelled out, although half will be left. So we will get equation 2 moles of carbon, it will combine with 3 moles of hydrogen and half mole of oxygen, it will produce ethanol molecule. Also the heat content or the enthalpy is also calculated by sum of delta H1, delta H2 and delta H3, and we will get minus 241.96 kilojoule per mole. That is the heat released during the formation of ethanol.